Hey guys, welcome to Codeforces Every Day until GM Day 61. Just gonna jump straight into it, recording this video kinda late today. I probably should have done it earlier in the day, but woke up pretty late in general, so hasn't been very productive of a day for me. It is my spring break. But yeah, just gonna get my daily video out for you guys. Okay. I don't even know how to pronounce this question. Matryoshkas. Matryoshkas. Okay. Oh, it's the wooden dolls that like the nesting dolls? A set of nesting dolls contains one or more nesting dolls. Their sizes are consecutive positive integers, thus a set of nesting dolls is described by two numbers, S, the size of the smallest, and M, the number of dolls. Okay. The set contains sizes S, S plus 1, all the way to S plus M minus 1. Okay. If you had one or more sets of nesting dolls. Recently you found that someone mixed your sets and recorded a sequence of dolls sizes. You do not remember how many sets you had. You want to find the minimum number of sets you could have had. Okay. 2 sets. 1, 2, 3, 4, and 1 and 2, 3. Okay, I see. I understand. So what is the min size of a set? Like, can it just be one doll and that's a set? M is greater than 0, so it can't just be one doll. Okay. I think this is actually pretty simple. I can see an idea of where I should go. For I in range, but yeah, I'm worried it's a little bit more complicated than I think it is. Because just reading the question, it seems pretty straightforward. N equals int input, and then A equals list map int input split. Okay. So minimum number of, so for this one it's 2. Okay. Number sets. Okay, it's actually a little more complicated than I thought. Because originally I was just thinking you would count the number that shows up the most. But no, there's cases where it's you can have one, what is this? 1, 2, 2, 2, 3, 3, 4. And then 6. Because this will have something. This one would be probably 3, right? This would be 1, 2, 3, 4, 2, 3, and then just 2. And then you'd have 6 on its own. Now it's 3. So it's not just the max. Or now it's 4. So okay. I think you want to greedily build substrings, right? I'm thinking you want a count array. Let me just see. 9, 8, 9, 10, 11, so this one's 1. And 6 because they're all the same size. Okay, here's what I'm thinking. And then it's like 0 times n minus 1. So this is an array from 1 to n, right? And then we should sort it. Or we don't sort it. We just count this. Well, I think we should sort A either way, right? We sort A, and then we count it, and then for each number, like we try to build, we check like I plus 1 or something. If it doesn't exist, we increment R to print by 1. And then we move on to the next number in the sorted array. Or, no, let me think. We have a count array. We basically iterate through the count array until like, okay, it's kind of hard to explain. I think if I code it a little, I can visualize it better. But first we need to do a.sort. And then we need to do count equals this times n minus 1. This should have a 0 in it. And then for in a, for num in a, count num minus 1 plus equals 1, and then print count. Integer out of range n minus 1. Okay, this is an issue. That I think can be, oh, I see what's going on. It's not the count of numbers, it's the max of numbers, so we could just use a dictionary. Like, nothing's stopping me from using a dictionary, but there's some like overhead to using dictionaries that I don't completely understand. There's some questions where if I do it like with like an array, it's faster than using a dictionary. And I have a feeling this question might come down to that. Like, I might end up like TLEing. But for now, just to solve the question, we can use a dictionary. Count equals, well, we can use a counter now. From collections, import counter. Count equals counter a. Print count. Okay. We have a sorted A and we have a counter now. Now, what do we do with this? We we care about the sorted A at all? I don't think so. I think we actually want to set A. We'll set A dot sort. I think I need to do sorted A. And account A. So for num in set A, here parent equals 0. For num in set A, what happens? So given this case, 1, 2, 2, 2, 3, 3, 4, 6. This is our A. Our set is 1, 2, 3, 4, 6. Our count is 1, 1, 2, 3, 3, 2, 4, 1, 6, 1. Right. Then we want to start with 1 in the set. Let me see. I'm seeing two loops no matter what I do. So I'm thinking I just check for nums plus 1, nums plus 2. I would take the min. Or okay, so brute force way would see 1, check n plus 1, then minus 1, check n plus 1, minus 1, check n plus 1, minus 1. Check n plus 1 doesn't exist, so we end here. And then we start here. Check n plus 1, minus 1. Right, we start Our starts is obviously -1. And +1, -1. And we end here. And we go here. -1. We can't go anywhere. And then we go here. -1. So this becomes 1, 2, 3, 4 layers. But this is in squared time complexity. I don't really see a faster way. Mm. So let me think. Is there any like math representation of like the number of, because this is the interesting part, right? How can we derive 3 from this? Well, our max is 3. This is all a substring. So given a substring, to print plus equals mode, right? And then we can ignore all of that substring. Now what if there's two okay, well, now we need to split it into substrings. So that can be done in O of 1. Oh, O of n. Right. I think that's the first step to this entire thing, actually. Given an array, should sort it still. And then we start from the first one. How do we do this? It's so given this array, 1, 2, 1, 2, 3, 4. It should be a set. We should. Okay. Set A equals set sorted A. And then substrs. Then for I in range, start from 1, then set A. If Ri, if, okay. Set A. Equals set AI minus 1 plus 1. We need a cur. I like cur equals empty array cur dot append I set a I else subster dot append cur I'm so used to typing cur with 2 R's. I don't know why this decided to be special. But with 2 R's looks so weird. I don't know. Maybe I need to change my habit. Yeah, okay, let's go back. Cur is equal to empty array. Print substrs. Okay. New test case 1. The length of this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 2, 2, 3, 3, 4, 6. And this empty array is short. Cur.append set AI. Alright, first things first, we need to print set A. One, two, three, four, 6. That looks right. Now, for I, oh, this is supposed to be 1. Set not subscriptable. Okay, let's put it back to a list then. He's so freaking annoying. No, this ain't right. 2, 3, 4. I guess we need to set cur to subster 0. Right. Sure. Index out of range. How does set A0? There we go. 1, 2, 3, 4. And then we need to set this to set AI. Right? No? Something is okay. Can't set it to empty array because oh, I probably need to substance.append cur. There we go. Okay, now that I have this abomination, I'm wondering if I should modify it. This is cool and all, but how do you find the mode of this? Instead of making them substrings, what if I made them like dictionaries? Oh, I could probably still have a counter, right? I can do counter equals counter A, and then to print equals 0. For subster for list and for nums in subster. So we have a counter in basically an array of keys, and we want to get the max value out of that array of keys. So to print plus equals max counter key for key in num. Something like this, I guess. Instead of printing substrs, print to print 4. Okay, I think that's expected. That 100% is expected. Alright, 1, 2, 3, 4. And we run this 2, 1, 6. Okay, it fills the last case. Let's specifically look at this case. It's supposed to be 3. We get 2. Why? We have 2, 2, 3, 4, 4. We're going to make 2, 3, 2. Oh. But what my shit does is see 2, 3, 4. In mode. Okay. This don't work. I didn't even consider this case. So it's not the mode, it's the most we can get away with of the subster. It's the min. But then we got these 2 leftover ones. How did those work? Two, 2, 3, 4, 4. We find the subster 2, 3, 4. We're given the subster 2, 3, 4. we remove it. That's too slow. It's gonna be too slow. I can't just recalculate the substir every time. So it's like, okay, this is like a mountain and valley. If it's 1, 2, 2, 3, and 1, 1, 2, 3, 3. You know, these are two cases. It's like X, Y, Z, X, Y, Z. We have X, X plus 1, X. X plus 1, X, X plus 1. So this means I can have 2, but this means I don't even think, okay, what's the best way to visualize this? I'm thinking like this. We can group these. This one is like boom, 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 4. Like you group these first, and then you have these separate ones. Right, so I think I have to rewrite some of this for sure. I don't think it's this. This isn't gonna work. I don't think this works at all anymore because now we have to deal with something else. Let's define a two-parameter variable. We have a counter. And what if we check the ones next to it? So like how can we know how many sequences each number can create? Okay, 1, 2, 2, 3. 1, 1, 2, 3. This depends on. Okay. What if 1, 2, 2, 3, 3, 4? What if this was 5? One, 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 two, two. So it's like your plus equals. If this is x and this is. This is what? Let's not use x. This is I plus 1. We're talking about the indexes here, not the values. Of counter. This is counters like keys. It'd be 2. We have 2. We have 2, 2, 2, 0. I guess to create, like, I think we have to look at this to see if we can create a new substring. To see how many substrings we can create with the given, we have to check the one before. Right? Because if I appears, if I plus 1 appears more than I, the extra copies are substrings, or can be used as new substrings. It's not in this case. But if we were to have this case, 1, 2, 2, 3, I plus 1, I plus 2, okay, boom, boom. So in this case, we check the first case. The previous case is 0. So this can be used to create one substring. right? Because this appears one more time than I minus 1. There's plus 1. This appears twice. I minus 1 appears once. So this can be used to create one more substring. And then this can't be used to create any more substrings. So I think it's like we compare the current to the previous to check for leftovers. The leftovers can be used to create more substrings. Like even if this 3 didn't exist, it would still be 2. Right? The current doesn't matter, really. We are really... Well, the current is just a conditional check for the future values. Something. Okay, let's try a case like 1, 2, 2, 2, 3. We check with the original, so this is plus 1. This one, check with the original. This is plus 2. We check with the original. It's negative, so we can't make any, so this is 0. So in this case, it's this, this, this. It's 3. Okay, I think this is it. Let's check with our earlier 1, 2, 2, 2, 3, 4, 6. So this is always plus 1. We can make one substring from 1. This is, we can make 2 more substrings, because 1 takes basically all these, right? We can make 2 more substrings from these 2's. Plus 2. Or, it doesn't take 6. Right? And then, we can't make any additional from this, we can't make any additional from this, because these all are negative, or 0. And then, this one, previous is 5, so it's 0 5s, which means this is plus 1. Yeah, because the actual grouping for this is 1, 2, 3, 4. Sorry, let's make that better. 1, 2, 3, 4. And then this is 1, 2, 3, 4. Okay. And then the other case, 4, 2, 2, 3, 4. It's always just better if we sort it. 2, 2, 3, 4, 4. We do check previous, so this is plus 2. We can make 2 substrings from 2's, because this takes 2, 3, 4. Check 3, we can't make any additional from this. Check 4, we can make 1 additional, plus 1. This is 3. 1, 2, 3. Yeah. Okay. I think this is it. So we have a 2 print for num in counter doesn't automatically sort it, so we need it sorted. Sorted counter to print plus equals counter num minus counter num minus 1. And then we need to check for the base case. So we should actually use like .get. If it doesn't exist, it's 0. .get x .get num minus 1 and 0. Right, because 6, 5, 5 .get by default 0. And then if it's negative, it's 0. So we can actually just wrap this in a max. 0 comma this. Right. Okay, yeah, that worked. I mean, the coding was pretty simple for this. Seeing the logic was quite difficult, I would say. I definitely need to bookmark this question. But let's hope it works. TLE is over. It's time to end myself. TLE. So is it because I sorted counter? Is it the dictionary overhead? It might be the case. I knew this would happen. How did I just know this would happen? How can I make this faster? Sorting this makes it log in. So how can we do it in O of n? For num, we can't use this. We cannot use sorted here. That's an extra log in. So we need to use like a range. A range from what? From 1 to... What does sorting do? It sorts it. What matters? What is the last number? Like n? No, n is the length of the array. We want the actual number, which is largest possible number, max a plus 1. And then since we do num minus 1, okay, this should be a range. I think we can replace this with a range from 1 to max a plus 1. And then what? 0 counter num. I think everything else can stay the same. We no longer need to .get, right? Because, wait. something's not right. What is actually happening? From 1 to max. Like, this question is actually a language diff. Test case 27. Like, if this was C++, it would just pass. But I don't know. What is the counter equivalent in C++? Like, I'm running into this a little more often. I'm wondering if I should just completely pivot to C++. But I like Python. I really do. And I do not like C++. I don't know if I'm just too stubborn. Iterate through in. Oh, I guess we don't need a sort at all. Right, because this is a dictionary. We don't really care about the order. So we can just do for num in range 1 through n plus 1. 2 parent plus equals num. Wait, does this work at all? No. Why do I feel like this will throw me an error? 0. Why is this returning 0? Eight. Ah, I did not mean to click that. Bruh. Whatever. Why is it returning 0 for 8? Why is it returning 0 for everything? That's a question. Right. So, print num. Five. Okay, no in. Max A. +1. I think that's it. I think that's what was causing the issue. Okay. Oh my god. This is taking forever. This ain't it, bruh. We got rid of the sort, but it made it so much slower. TSPMO. This is language diff, man. C++ would have passed. here's what we can do. Check for 1, 2, 2, 2, 3, 4, 6. The same logic. This is plus 1. This plus 0. This plus 0. This is plus 1. Plus 1. Or no, it's triple. So if current value is greater than the previous value, we check if cur minus pref equals 1. If it is, so okay, we can track the current value. I think we can do this without a counter at all. But we need to sort, we need to do like a.sort. And then, okay, let's just start from scratch. We can track the current value, cur count 0. We can track the need to print, and then we need like sequences. Then if we need a loop for just iterate through for each value in A, or num in A. If we low-key need to check two conditions. and it's well, so a sequence can only extend if the next number is +1. So while scanning the numbers, we can track how many times the current value appears, how many sequences from the previous values from the previous value can continue, and then the number of sequences created is to print. So if the cur count is greater than our sequences that we're going to extend, then print plus equals 1, we start a new sequence. If it's equal to, then we just move on to the next number. And if it's less than, we end that sequence. We don't need to track when sequence ends. We only need to track the sequence starts. Right? So if num is greater than rev, we should track a previous variable. Which this should be the case as long as they're not equal. If they're equal, our cur count should plus equals 1. Okay, let me look at this logic. If num minus prev equals 1, then our sequences should be set to cur count. If not, we reset our sequences to 0. This is right, and then we set our prev to num. There's Joe over, bro. I don't know what's happening. Somewhere my code is wrong. But I don't think this works. I think my other way was way better. It's over. I might need to pull out the C++. I can't figure this out. Okay. CNT. So test cases. While t minus minus. So we iterate through every t. I don't know why I'm adding spaces everywhere like a freak. We take in int. Then we take in a. No arrays in C++, they are vectors. Should be vector int, so it's a data type, and then a length in. Oh, this should be in. Okay, and then map int, and we can call it counter. I barely remember how this language works. Okay, now I need a for loop. Bro, chill. For int I equals 0, I is less than in, plus I. We see in all the values of a. Semicolon. Counter a I plus semicolon. So this should take in all our inputs, right? Int to print equals 0. Now we write this part. Let me think. I think I can use this. I don't remember how it's like for auto and like this. Like they're gonna be number and frequency. Counter. Is this it? I'm gonna Google this real quick. Last time I used C++ was like years ago. It's like range C++ range based loop. Range based declaration range expression. I think this should work. If it doesn't work, I'm about to crash out. I'm low-key about to crash out on this question, bro. It's been an hour and a half. And I think like my solution is a solution. It's just language diff. Int prev frequency prev rec equals counter dot count num -1. Okay, the rest of this is pretty straightforward. And then use a conditional operator. Counter num -1. And if that doesn't exist, we set it to 0. Semicolon. And then to print plus equals max 0 frac minus prev frac. The space uses our space. And then the out to print. Oh, it's over. Backslash n. Okay, we got it. Please speed. I need this. Bro, this is so C++, there. It's the same code. It's the same code. It's just language diff. That's crazy. It's the same code. Alright. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys tomorrow. This question pissed me off. Bye.